Prepare for a remarkable journey as we introduce 9 stunning images that redefine the horizons of space exploration with the revolutionary James Webb Space Telescope. Get ready because the universe just got a lot more intriguing. As we continue to explore, we must remember that every patch of sky has its unique narrative waiting to be unraveled. Let's dive into our first image, a captivating glimpse into the radiant core of NGC 2217. Have you ever gazed up at the night sky and pondered the dazzling mysteries it holds? Among these celestial wonders resides NGC 2217, also known as AM0619271, nestled within the constellation Canis Major, often referred to as the Greater Dog. Imagine a distant, shimmering cityscape, situated approximately 65 million light-years away from us. It's so far away that the light we perceive from it today embarked on its journey when dinosaurs still roamed our Earth. NGC 2217 is no ordinary galaxy, it's a barred spiral one. When we typically think of a bar, it might conjure images of a long, straight piece of metal or wood. However, in the cosmic context, this bar is composed of countless stars densely packed together, radiating light and creating a luminous central streak. This galaxy shares a similar size with our own home, the Milky Way, spanned approximately 100,000 light-years from end to end. Just imagine embarking on a journey across such a vast expanse. It's a voyage that would last an incredibly long time. But why is this central bar so significant? In galaxies like NGC 2217, this bar serves as a kind of cosmic conveyor belt. It efficiently directs and channels gas from the outer regions of the disk towards the galaxy's central regions. Once there, this gas and dust have 2 main destinies. Some of it coalesces under the influence of gravity to give birth to new stars, adding to the galaxy's already radiant population. However, others have a different fate. They are devoured by a lurking behemoth, the supermassive black hole at the heart of the galaxy. Now you might be wondering, what exactly is a supermassive black hole? Visualize it as an invisible abyss with gravitational pulls so intense that nothing, not even light, can escape its grasp. These cosmic entities are often extraordinarily massive, ranging from a few hundred to over 1 billion times the mass of our Sun. Surprisingly, nearly every large galaxy, including NGC 2217 and our very own Milky Way, harbors one of these enigmatic giants. In the grand tapestry of the universe, NGC 2217 serves as a shining example of how galaxies evolve and transform, driven by their internal dynamics and the colossal forces that reside at their cores. Let's shift our focus to our second image, a captivating view of the mysterious galaxy, NGC 5408.
Recognizable spiral or elliptical patterns. But have you ever stumbled upon one that just doesn't fit the mold? One that, instead of following the norm, champions its own chaotic, unrefined form? Enter NGC 5408, a galaxy that refuses to be boxed into typical descriptions. NGC 5408, residing in the constellation Centaurus, was first jotted down by the English polymath John Herschel in June 1834. But there's a twist. For the longest time, it was masquerading as something else. Astronomers for years assumed it to be a planetary nebula, which is essentially an expelled, glowing shell of gas and dust from an old dying star. But NGC 5408 had other plans. It later revealed its true identity as an irregular galaxy, situated approximately 16 million light-years from our home planet. Now you might wonder, what's a light year? Simply put, a light year is the distance that light travels in a year. So when we say NGC 5408 is 16 million light-years away, imagine the immensity of space that light has to cover for 16 million years to get from NGC 5408 to Earth. Diving deeper into NGC 5408's peculiarities, it houses a mysterious entity named NGC 5408X1. This isn't just any celestial object, it's an ultra-luminous X-ray source. Think of it as a cosmic lighthouse, but instead of light, it emits a massive burst of X-rays. Such sources are incredibly rare and intriguing to scientists. But why? Astrophysicists speculate that these ultra-luminous X-ray sources, including NGC 5408X1, might be hiding intermediate mass black holes within them. But wait, what's an intermediate mass black hole? Picture black holes in three sizes: small, medium, and large. The small ones form when gigantic stars end their life in a fiery explosion, while the large ones, or supermassive black holes, can be billions of times heavier than our Sun and typically lurk in the centers of galaxies. The intermediate mass black holes, however, sit right in the middle. They're heftier than the stellar black holes, but nowhere near as massive as their supermassive counterparts. NGC 5408X1 might just be holding one of these elusive middleweights inside. Now let's venture into our third image, a captivating portrayal of the cosmic ballet, where bars and berths entwine in a celestial dance. Have you ever found yourself captivated by the spinning motion of a pinwheel? Now envision a colossal pinwheel in the vast expanse of space, intricately crafted by stars, gas, and cosmic marvels. This is NGC 7541, a galaxy that proudly wears its designation as a barred spiral and resides within the constellation of Pisces, often symbolized by the fishes. So what sets NGC 7541 apart from the countless galaxies scattered throughout the universe? For one, this majestic entity has been meticulously captured in intricate detail by the James Webb Space Telescope, granting us a glimpse into its cosmic intricacies. But there's more to this celestial story. At the core of this galaxy lies a unique feature, a luminous bar composed of gas and stars. Picture this bar as a bustling city center that breathes life into its surroundings.
As it traverses through the galaxy's heart, it plays a pivotal role. The bar stirs up activity, reinvigorating processes that may have lain dormant or igniting entirely new celestial events, such as the birth of stars and awakening of active galactic nuclei. But why is this significant? Well, imagine you're in a vast cosmic kitchen, intending to cook up some stars. You'd require ingredients, right? These bars effectively serve as cosmic chefs, gathering the necessary materials and propelling them toward the center, creating conditions that are just right for birthing new stars. It's akin to adding fuel to a fire, intensifying the brilliance and warmth. Evidence suggests that such bars are far from rare. In fact, they might exist in nearly 2/3 of all spiral galaxies. And here's an intriguing tidbit. Our very own Milky Way, our galactic abode in the universe, is believed to possess one of these bars as well. Remarkably, NGC 7541 isn't just any barred spiral galaxy. It boasts a higher rate of star formation than most, supporting the notion that these bars may indeed serve as cosmic nurseries. Like diligent caretakers, they gather the essential elements, channeling them inward to craft and cradle brand new baby stars. As we delve deeper into the universe, galaxies like NGC 7541 serve as poignant reminders of the ever-evolving nature of space, where bars aren't solely about stars, but also about the birth and rebirth of cosmic marvels. Image 4. Stellar salts intricately woven into the cosmic tapestry. Imagine spilling a pinch of salt onto a dark canvas, each grain glowing with its own distinct brilliance. That's the visual spectacle that NGC 1755, an open star cluster, offers to our eyes through the lens of the James Webb Space Telescope. This sparkling assembly is nestled within the Dorado constellation, often likened to a goldfish in the vast aquatic realm of the cosmos. Located in our Milky Way's nearby cosmic companion, the Large Magellanic Cloud, NGC 1755 stretches an expansive 120 light-years across. Now, if you're thinking, isn't 120 light-years enormous? Here's a fun perspective. Compared to other celestial congregations, NGC 1755 is considered on the petite side. But what exactly is a star cluster? In the simplest terms, think of it as a family gathering of stars, all tied together by the unseen but powerful force of gravity. These clusters can be classified into two primary types. Open clusters, much like our very own NGC 1755. These are the more youthful bunch, brimming with younger stars, reminiscent of energetic teenagers at a family reunion. Globular clusters, the grander and more seasoned groups, home to millions of stars that have seen many more cosmic cycles, like the wise elders in a family. With its deep gaze, Webb delved into NGC 1755's heart, aiming to decipher the intriguing mystery of coexisting star populations within. When we talk about a population of stars, we mean a group of them sharing certain features, such as age or chemical makeup, just as humans of the same age group might have shared experiences or cultural touchstones.
Stars of similar populations can offer a collective story about their birth, journey, and eventual fate. Why is this important? Because understanding these populations in clusters like NGC 1755 offers astronomers a front-row seat to the grand theater of stellar evolution. They're like cosmic time capsules, preserving the tales of stars past, present, and future. And the Magellanic Clouds, given their closeness to our Milky Way, serve as excellent cosmic classrooms for this purpose. Our journey continues with image number 5, a mesmerizing glimpse into the luminous heartbeat of NGC 1433. Have you ever found yourself pondering the enigmatic wonders that reside within the vast tapestry of the universe? Thanks to the remarkable capabilities of the James Webb Space Telescope, we've been granted an intimate view of one such mystery, the spiral galaxy NGC 1433, nestled in the Horologium constellation, often associated with the concept of time. This galaxy lies approximately 30 million light-years away from our home planet, yet NGC 1433 isn't just your run-of-the-mill spiral galaxy, it's a Seyfert galaxy, a classification claimed by only about 10% of all galaxies. So what sets these Seyfert galaxies apart? It all comes down to their radiant hearts. These galaxies possess brilliantly glowing centers, emitting light so vibrant that it can rival even the center of our very own Milky Way. Now you might be wondering, what makes these galactic cores so fascinating, and why do astronomers appear so captivated by them? The answer lies deep within these luminous hearts. It is believed that at the center of most galaxies, perhaps all of them, resides a supermassive black hole, a cosmic behemoth. This black hole is surrounded by a mesmerizing dance of material inexorably drawn inward. So how do we go about unveiling the secrets concealed within these distant centers of radiance? Image number 6, peeling back the layers within the heart of a galaxy. Imagine standing on a beach, gazing at a vast ocean, with each wave carrying thousands of glittering particles. The James Webb Space Telescope offers a similar but cosmic panorama, revealing countless galaxies scattered across the universe. Picture each luminous point in this canvas as a distinct galaxy, with one lone shimmer not belonging to that distant ensemble, a star from our very own Milky Way that photobombed the view. Nestled at the heart of this stellar spectacle is the pulsating core of a massive galaxy cluster, WHL J243324.8+243. But this isn't just any cluster. It's the site of the leading galaxy which stands out like a lighthouse amongst chips in the celestial sea of the Cetus constellation. But how does the universe organize its vast collection of stars and galaxies? Let's break it down. Think of the universe as a city. In this city, stars are like houses grouping around specific blocks, which are galaxies. These galaxies then join hands to form local neighborhoods or groups. Taking it a step further, these galaxy groups merge to create massive boroughs or clusters. It's a cosmic hierarchy built upon the pull of gravity. This brings us to an intriguing question. What holds these colossal clusters together? The answer is partly in what we cannot see: dark matter and dark energy.
These mysterious entities are the architects of the universal structure. While they remain unseen and largely unknown, their impact is monumental. They're responsible for knitting together these galaxy clusters, and by studying clusters like WHL J243324.8+243, scientists hope to lift the veil on the enigmatic nature of dark matter and energy. 7. A celestial ballet among galaxies. In the boundless expanse of space, galaxies don't always exist in solitary isolation. On occasion, they draw so near to each other that they commence an intricate cosmic waltz, exerting gravitational forces that tug and sway them. This mesmerizing spectacle is precisely what the image of ARP-273, a pair of galaxies situated 300 million light-years away in the Andromeda constellation, captures. The larger member of this celestial couple possesses an unconventional silhouette, appearing somewhat stretched, twisted, and contorted. The question arises, what's the reason behind this peculiar appearance? It's akin to encountering footprints left in the sand, evidence that something or someone has passed by, leaving a distinctive mark. In the case of ARP-273, that something is its smaller neighboring galaxy. The prevailing theory suggests that this diminutive galaxy ventured so close that it traversed right through its larger companion. Picture two colossal and immensely powerful cosmic entities, with one piercing through the very core of the other. What unfolds when two galaxies intersect in such a manner? This captivating interplay provides us with valuable insights into the ever-changing dynamics of our universe. One can't help but wonder, how many more of these remarkable interactions remain concealed, awaiting discovery? How do such encounters mold the evolutionary narratives of galaxies? Each glimpse into the cosmos grants us a slightly clearer understanding of the vast tapestry of celestial stories that remain to be unveiled. Image 8. Peering deeper, the expansive reach of the Cosmos Webb field versus Hubble ACS field. When we cast our eyes upon the night sky, it presents itself as an immense and boundless expanse. Yet when scientists embark on their quest to explore it, they often narrow their attention to specific regions of the sky, striving to uncover intricate details within those carefully chosen areas. This is where the Cosmos Webb Survey and the Hubble ACS field come into play, offering two distinct but captivating viewpoints of the universe. Imagine for a moment that you're gazing at the night sky, and to your astonishment, you spot three full moons lined up side by side. That roughly represents the expanse the Cosmos Webb Survey intends to scrutinize. Covering an impressive 0.6 square degrees of the sky, this survey aims to capture a panoramic snapshot of space through the utilization of the James Webb Space Telescope's near-infrared camera and instrument. However, the story doesn't end there.
While the NIRCam is diligently documenting this expansive region, another part of the James Webb Space Telescope, the mid-infrared instrument, MIRI, is directing its focus toward a slightly more concentrated area spanning 0.2 square degrees. Although smaller in scope, this area holds the potential to reveal profound depth and intricate details. If you've ever observed a jigsaw puzzle in the process of being completed, you'll notice how individual pieces come together to form a coherent picture. The outline of the Hubble fields resembles this concept, slightly irregular and constructed from various images that, when assembled, provide us with a comprehensive view of that specific section of the sky. What stories and mysteries lie within these segments of the universe? Why might scientists opt for one area over another in their studies? Each choice, each focal point represents a journey into unraveling the enigmas of the cosmos, gradually expanding our understanding of this vast and intricate tapestry. In image number 9, we embark on the journey to decipher the core of our galaxy, presented as a vibrant mosaic captured in the infrared spectrum. As we journey into the heart of our home galaxy, the Milky Way, we're presented with a vibrant tableau that defies our ordinary vision. Through an intricate composite infrared image, the central core of the Milky Way unfurls secrets previously hidden from our eyes. This detailed view offers a mesmerizing mosaic, a fusion of colors that represent different temperatures and elements shining light on a region that stretches over 300 light-years. Now, why is this part of our galaxy so significant? Well, nestled within these cosmic confines, a new population of massive stars has been identified. These aren't just any stars, they're titans, carrying immense energy and profoundly influencing their surroundings. So, what can these stars and this vivid image tell us? The interactions and behaviors observed in this central region give scientists crucial clues about the birth, life, and tumultuous interactions of massive stars. Imagine being able to peer into the inner workings of nature's grandest factories of stars, right from our own cosmic backyard. And this isn't just about our Milky Way. This sharp, unparalleled infrared image provides a kind of local laboratory.
When astronomers peer into the fiery core regions of distant galaxies, they can compare their observations with what they see in the Milky Way's center. This helps them draw conclusions and theories about how massive stars form, live, and often end their lives in dramatic explosions in galaxies far, far away. Sitting roughly 25,000 light-years away from us and residing in the constellation of Sagittarius, this center is more than just a point in space. It's a testament to the dynamism and complexity of galaxies. With every new observation, especially ones as detailed as this, we inch closer to unraveling the mysteries of our universe. If you're as passionate about the wonders of the cosmos as we are, do us a favor. Like this video, hit that subscribe button, and click on the video appearing on your screen now for another exhilarating space adventure. Until next time.